radio and television. Right, that proceeds by the way we understand it, and the way it's all written down and the designs are done is in terms of electromagnetic waves, which are so the way that radio waves are generated and transmitted and received. You use something called Maxwell's equations, written down in the 1860s by James Clerk Maxwell. There is a better theory now, which is called quantum electrodynamics, written down by Richard Feynman and others. Actually, beginning in the 1920s, I suppose, certainly in the 1940s, 1950s. It's a more accurate description of electromagnetic radiation. But you would never design a television transmitter using quantum electrodynamics. You couldn't. It would be ridiculous overkill and you couldn't do the sums. So you use Maxwell's equations, which allow you to do something real, which is to build a television, which is exactly what you've said.
Will people in 100 years' time go, there was a mass delusion? People believed they were watching Brian Cox's Wonders of the Solar System, but in fact all the screens were blank.
Is it? Yeah. But that's the kind of almost the implication of that kind of complete misunderstanding of science.
So, for example, one of the good things that I like about bubbles, it's not a good thing in general, but if you have a glass of a fizzy drink and Coca-Cola, something horribly sweet, right? And you drink it when it's fizzy, it doesn't taste sweet. And then you let it go flat and it's disgusting in how sweet it is. And there's a reason for that. And the reason is that the bubbles, so there's physics and biology in this. Bubbles come out of solution, they carry carbon dioxide, and they carry it, when the bubbles going over your tongue carry carbon dioxide directly to your cheeks. And they irritate a nerve there which is looking for poison. And so what that does is switch off your taste. So when you have bubbly drink flowing over your tongue, you've also got your taste switched off. So you have to put loads and loads and loads of sugar in order to get any taste at all. So when you take the bubbles away, you can taste how sweet it actually is. And I guess it's a nice demonstration because you have bubbles coming out of solution. I mean, that's weird. You have a liquid and then suddenly bubbles are growing in it. That's weird, but you can see something about the world there. And then you have the interaction of that physics with the biology of being a human being. And it's such a simple thing. It's something that most people do every single day of their lives if you drink fizzy drinks.
So, having kids that ask difficult questions reawakens the wonder of science to you on a sort of weekly basis, because they ask you things you don't know about. It also scares me. I'm really scared about gravity now and about how it can possibly hold us all in the right place, and what would happen if it just changed a bit, because I had to talk to him. And when my son's having to push his bike up a hill or scooter up a hill, because we talk about it such a lot, he's 6, he goes, "Oh, gravity, I hate you," making it hard to get up this hill. So he's involved in a hostile war with gravity now as a result of science.
I bought Feynman's 6 Easy Pieces, right? And so originally, Richard Feynman delivered these as lectures which were for an advanced physics class, but were kind of to bring them up to speed. So the idea is you should really, if you've got a brain on you, this should kind of lead you in. Great, okay. So I bought Feynman's 6 Easy Pieces, and I read the first easy piece, and it wasn't that easy, but I got through it. And in the second, I was sort of halfway through the second lecture, and I turned a page over and began to read this page, and I thought, oh, I've missed a page. And I went back, and I hadn't missed a page. I just kept turning it over, and I couldn't see any connection between them, and eventually I had to close the book and put it away and think, the remaining 4.5 easy pieces are for the people who can do this stuff.